My name is Jakub Zikl, and I work as a software engineer at Prusa Research. Before everything, I just want to give you a notice from our HR that we'll be taking photos, so hope you don't mind. So that's before we start. Other than that, hope at the booth there is some food left or beverages, just a little. So if you want to feel refreshed, just go there, no worries. So I'm a software engineer working on the backend systems at the Prusa Research. Primarily, it's about printables.com and EasyPrint right now. I will talk more about that later. But here's the thing. There is no magic bullet for scaling systems. It's mostly about getting to know your tools and understanding what's running under the hood. I watched teams getting burned by overengineering. It creates chaos, the cost for development is higher, and the operational nightmares are there. But I have also seen what, from the other side, how far you can get by actually understanding what's running under your belt. So that's hopefully what we will talk about today. Scaling without the chaos. Firstly, about Prusa Research. Open source isn't something we do on the side at Prusa Research. It's fundamental for us. That's how we think the whole industry should move forward. I think it's empowering for everyone if we create something and share it with others. We might be actually, and we are quite often surprised what people came up with, and yeah, that's it, mostly. Sharing the ideas and everyone is benefiting. If you are interested in seeing what we are using and what we are contributing to in terms of open source, here's the QR code which you can visit. And just TLDR, we are using Kubernetes, Argo CD, Crossplane, DevGuard, Python, of course, and many more. So if you want, you can scan it and give it a go. Back to our talk. Let me get a quick sense of who is here today with a few questions. So who here works on something where performance actually matters? All right, kind of surprised it's just like 50%. Was expecting a bit higher. It doesn't matter what's actually there. If it's an API or machine learning or you are processing just some information, it's about everything. The second question is, have you ever added a new tool or service or something which you hoped would essentially help, but it turned out it might not be the best choice? Again, be honest. All right, about the same percentage. Thank you for honesty. This is something I want to talk today about. As I mentioned before, I work on printables.com. Does anyone know here what's printables.com? All right. So, simply put, it's a massive platform where people can download and share 3D models. These models can be loaded into the big boxes, which you can see over there. And based on these, you can print basically everything. And that's what we like. Just like I said, open source, you can create a model of everything and print it later on. However, keeping something like that running and stable sounds like a real challenge. So even though it's a challenge, it's also fun. So let's move on. As you can see, we started in 2018, I guess, at And what initially began as a basic file sharing web application has grown into something much bigger. Today, printables.com is one of the largest 3D printing platforms where people can share the models. And not only that, we are building communities. People can like their models, follow each other, gain badges, like the models, even send private messages. It's like the whole ecosystem. And not only that, we became de facto the onboarding platform for 3D printing newcomers. So if you find yourself thinking about the 3D printer, you are more than welcome to check the printables.com, where you can find the 3D models, and maybe that will convince you. These numbers over there aren't just bragging rights. I think it tells the story. We are processing billions of API requests each month. We recently hit 1 million published models on the platform from users from all around the world. Either it's teachers, engineers, hobbyists. We are processing over 80 terabytes of data, which is STLs, G-codes, images. But I think the most important part about this is we are not running on something fancy. We are running on basic Python stack, which is powered by Django. We are utilizing the GraphQL layer. We are using Celery for async tasks. We are using Postgres, Elasticsearch, everything running on Kubernetes. We discovered something really important. It's not about fancy tools. It's about making smart decisions. Let's dive into the overengineering. In my experience, the good way how to test if your system is overengineered is to try to explain how it works to maybe a new team member. If you are able to do that within a few minutes, I think you are on a good track that it's not overcomplicated or overengineered. If it's otherwise, chances are you are maybe overengineering. However, it's not about avoiding complexity all the time. There are situations where the complexity is needed. However, this is about avoiding unnecessary complexity. So, you have probably heard questions like, can Python scale? Can Django scale? Can this text scale? And the honest answer is, yes. These texts scale probably way beyond what you actually think. The real issue or limits basically and usually come from your understanding, not the tools themselves. And scaling isn't about stacking and throwing more technologies onto your stack and hoping it would eventually work. By the way, thanks for the 50%. Glad I'm not alone. What essentially worked best for us is starting with good monitoring from the start. Having the insight, having the observability, and the discipline to basically measure everything. This is how we build systems that grow and scale smoothly. So, where we focused our efforts? We began with a clear goal to keep our P99 latency under 400 milliseconds. Does anyone have an idea why 400 milliseconds? Nobody? All right. So there is a study which says humans have this threshold, which is 400 milliseconds. If it's under this threshold, people feel it as instantaneous. So they feel it's right away. And since we want to have our systems loaded for people right away, not just in metrics, but for real people, we picked this as a goal. And we went for good observability. We set up Grafana dashboards. we provided good metrics, and we set up alerts. Not only alerts based on these metrics, but even alerts for, let's say, slow loading of the website or any regression. So the idea is we should be the first one who is aware of some bug or regression, not users. Speaking of application performance monitoring, we are utilizing Django Silk, PySpy Sentry. You might or might not be familiar, but essentially these tools are just tools. It's mostly about understanding what's running, not using some fancy names. When performance issues arise, this is what really helped us. Having precise measures and not guessing. And based on these, what we tried and what really helped us was betting on small wins. For example, if you think about 10 fixes of your latency, each one of these is just 5%. When you do 10 of these, it's essentially 50% faster system. So why not? The idea is to fix the slowest 1%, not the fastest 99. And you don't need fancy architecture diagrams or tools to do that. You need clear visibility and understanding how your system actually works. And I think this image speaks for itself. It's about no more refactors, but understanding the code or your system. So, speaking of what helped us scale at printables.com, we are not alone, but we are caching. And since caching is everything, there is a caveat. You need to cache smartly. You need to cache right things, set smart expiration times, and handle cache updates with, for example, pre-warming. So when you do a deploy, you are not, the latencies are not spiked. As I said, we are using GraphQL, and that brings N+1 issue where you are essentially doing too many queries. We are fighting that by prefetching and batching related data. So we are trying to shrink the number of these database requests. Since we are growing quite fast, we are pre-calculating stats like likes count and downloads count. On printables.com, where you see the model, you can see the actual likes count and downloads count and stats like that. These stats are something we are proud of, and we are trying to make them as precise as possible. As you will see what challenges that might bring. We are doing batch operations to reduce overhead during off-peak hours. So during the peak, it's stable and running. What's quite important is close coordination between our backend teams and front-end teams, because at the end of the day, the product for us, the printables.com, is a result of efforts from both of these sides, not just from backend or front-end. And I can't stress this enough. You need to focus on observed issues instead of issues which you think you might have or sounds like you might have it. Also, we love Pareto's principle. Basically, put efforts where it makes sense. It doesn't make sense to throw 80% of your efforts to get so much result. You need to do it otherwise. Let's talk about case study, handling concurrency encounters. As I said, we are handling likes counts, we are handling downloads counts, views counts, many counters. And let's see what challenges that brings. Let's start with a simple example. So you have a web application and that's connected to a database. Essentially, in the real world, on a server you will have multiple processes and you will have multiple servers. So scaling based on the process when there is no concurrency isn't an option. You need to think beyond that. The most obvious approach could be the first one. Basically, when a user does the like, which is over there, some logic follows, and you need to update the likes count on the model. So what you can do is recalculate the likes count every time. So you take the likes on the model, do the count, and update it. That works. Just like the second one, you just increment it by 1 from what you have in the memory. However, this is not the best idea. Both of these approaches have a serious flaw. When you imagine there are two processes, basically two requests from two users in the real world, where these people access one model and they do like at the same time. When we are talking about these two approaches, what happens is they get into the memory the likes count, which is essentially 0, and they both update it to 1. So the first one might do it, and the second one will override it, and boom, there is a race condition, and your counts are off. And that's probably not what we want to aim for. Let's see if there are better approaches. Another approach could be wrapping everything into transactions, basically locking the row with the model, incrementing the likes count, and updating. That translates into this query in the database. And what it does is it locks the row. So the process which is basically trying to do the update is guaranteed to be only one who is doing the updates. However, even though we got rid of race conditions, that actually brings even bigger problem, which is performance. Because right now, one user is doing the incrementing of the likes count. However, if you think about the model, which is popular, and there are many people doing the likes at the same time of the same model, they will essentially wait in the queue till the first request is finished, the likes count is incremented, and then they can do the incrementing as well. So this is not scalable. In the last example, we fixed race conditions with select for update, wrapping everything into transaction, but that created a performance nightmare. There is a better approach. We can utilize the F expressions of Django and basically say, we don't care what we have in the memory. We just want to increment it by 1. This above translates into updating +1 from whatever is in the database. So we are handling the concurrency issues to the database, and it fixes the race conditions issues, and we have precise counts. So no transactions needed, no race conditions needed, everything works. We can also tune it a bit further, but for now, we are good. And here is what I would like you to take away from the likes count example. You don't need to overcomplicate the solutions. Sometimes it's just about measuring what's slowing you down and optimizing it. The key is to measure. Measure twice, cut once. There's no point in tearing everything apart and then doing huge refactor. You can sometimes think about the simplest fix, which was the F expressions for us, and that might be the best fix for you. One really important thing is you build it, you own it. Since you develop this habit, you essentially grow and your understanding of the system grows, and you get many benefits from that. You understand how your system behaves under the load, where it has flaws, and you can improve it far by the most. Just like I said in the previous slides, small wins add up to big results. They compound. So basically, don't be afraid to do 5% optimizations, because if you do 10 of these, you get 50% faster system. Which brings me to the core principles that we have guided us through scalingprintables.com, where it is today. Even though that was mostly lessons learned about web development, we believe the principles from these apply to any industry, whether you are in machine learning or processing some data or something. When you abstract yourself enough, what you can see is you are getting data from somewhere, you are doing something with it, and you are returning the data somewhere or storing the data somewhere. What we recommend to start with is setting a clear targets. Define what success looks like, and then try to achieve it. Measure what matters. Don't make assumptions. You need to know the real data and let the real data guide you. As I said before, you need to improve step by step. There's no point in huge refactoring your application. Sometimes you just need small step, small F expression, and you are golden. And keep it simple. You need to solve the issue you have, not something you might have or you think you have. The tools are great, but understanding your system is much better. You need to understand what's running under the hood, how it works, what are the strong and the weak sides, and then you can work with that. Well, thanks for listening. I hope this gave you fresh perspective on scaling.